Unit 7, Part 7. I'm just running through a few of the rules, explaining how crucial it is to be focused on the potential applications of the rules, right? Making a few remarks about the kind of situations when you will need to use these rules, right? Don't read through the rules and just think, oh, that's a very simple rule, I understand that, right? You'll be tested on, and you need to be thinking of and aiming at the potential applications of it, right? When will this rule be useful, right? What does it allow me to do, right? So just a few remarks. The first one, simplification, which is an extremely simple rule, right? I'm giving you all the abbreviations, of course. Simp is the abbreviation for simplification. You'll be given the abbreviations as the justification, right? So if you if you're doing a proof, you've applied the rule of modus ponens, you've written the justified step, what you write then for the justification is m.p. MP, modus ponens, right? Look through some sample answers from the very back of Klenk when she runs through answers to some of the proofs, and that's how she does it, right? There's simp for simplification, MP, modus ponens, MT, modus tollens, dil, dot for dilemma, right? Just the abbreviation is what you give for the justification. The rule of simplification is a very simple rule. Also, I'll say a few things. Make sure you keep different rules distinguished in your mind, especially, as I'll say at the end, conjunction and addition. Don't confuse the rule or the form of those rules. But we'll get to that. Simplification, right? What is the rule of simplification? It's just, this is it formally presented, it's just, given any conjunction, you're entitled to infer either conjunct. Given any conjunction, you're entitled to infer either conjunct. This is one of two forms of the rule. If you look at the inside cover of your book, some of the rules have two forms, like disjunctive syllogism. Also, right, the other form of this is just, as you'd expect, P and Q, therefore Q. That's why I say it is, given any conjunction, you're entitled to infer either conjunct, right? So this rule, basically what you should be thinking for it is, whenever you're given amongst your premises a conjunction, straight away you could simplify, right? It should become a habit, second nature. The application of this rule should become second nature whenever you see, either amongst your premises or as you apply rules to your premises and come up with the justified steps, if a conjunction appears, an application of top-down reasoning, which is just deriving what you can, looking only at the premises, contrasted with working backwards, which is looking at the conclusion and working backwards. Talk about that at length. I will talk about that at length, but the rule of simplification is just a top-down second nature rule where whenever you see a conjunction, right, simplify, right? Two justified steps can be done immediately, right? Oh, look, I have a conjunction in the premises, right? A and B. So let me go, boom, A, simp, comma, 1. B, simp, comma, 1. Same justification, because you're appealing to the same premise. Notice it's a rule with only one premise. Most of the rules in Unit 7 have two premises. One or two of them have three premises. Dilemma has three, maybe it's the only one. Modus ponens, modus tollens, disjunctive syllogism, they all have two premises. But this one only has one, so if you just see one line, it's a conjunction, you can simplify. Easy as that. Okay, a warning, notice that you can recall what you cannot do with these rules. Recall from, I mean my lectures. Lectures on Unit 6, where we discussed logical implication and logical equivalence, and we looked forward. This is covered in Section 3 of Unit 6. There was the discussion of the relation of those relations, logical equivalence and logical relation, the logical equivalence and logical implication, to these rules, right? Logical implication is the relation of the premises to the conclusion in all these rules introduced in Unit 7. Logical equivalence, recall, that's the relation of, that's a relation between the two formulas on both sides of the double dots of all the rules introduced in Unit 8, which appear in the bottom half of your book. Unit 7 rules, top half of your book. It's relation of logical implication. And because of that, because it's Unit 7 rules are the relation only of logical implication, not logical equivalence, you cannot use these rules on subformulas. Okay, so this would be even more important to remember after Unit 8, when you've been introduced to the set of replacement rules, bottom half of your inside cover, when you've been introduced to a set of rules for which you are allowed to use, that you are allowed to use on subformulas, because then you'll have to remember, some rules I can use on subformulas, some I can't. Which one was simplification again? Can I use that on subformulas? Big time no. Very important to remember that you cannot, okay? Let me convince you of that, right? Simplification, given any conjunction, you are entitled to infer any conjunct, right? A condition for the application of the rule is that the premise is a conjunction, only on full formulas. You cannot use these on subformulas. So if the major operator of the formula is not a conjunction, the condition for the application of simplification is not satisfied. If the major operator of saying that again, if the major operator of a formula is not a conjunction, if it's a conditional or something else, you can't use simp. Okay, so you would not be able to use simp here, right? This is, I've got if A and B, then E. I want to get to A hook E. Can I? Can I just go simplification, simp 1? Is that a correct application of the rule? No, it is not, because the premise here, or this step 1, this is not a conjunction. Rather, it is a conditional. Right? The major operator is not a conjunction. That's a mistaken application of the rule. Now, convince yourself that this is a good restriction. Convince yourself that you don't want to be able to make that rule. We're doing proofs. We want every step to be a truth-preserving step. We want to rule out the possibility of moving from things which are true to things which are not true. Right? If the things from which we're coming, the premises or the justified steps we've derived, if they're all true, we want it to be assured that every step that is further derived is also true. Our derivation must be truth-preserving, right? See that this is clearly not, right? Let A equal Dan is Australian, B equals a bomb drops on New York City tomorrow, and E is everyone dies, okay? First premise seems to be true. If Dan is Australian and a bomb drops on New York City tomorrow, then everyone in New York City dies. Seems right. Thankfully, we cannot infer from that. We would be moving from something true to something false to infer, if Dan is Australian, then everyone dies. That's not true. Thankfully, because I am Australian, let's hope B is false. Right? Okay. So that little intuition there, I gave you a counterexample to this form, as it were. It's good to keep your mind on such things, to know what you're doing, to have some notion in your mind about how we're trying to preserve truth as we move through the proof. But a lot of what we're doing now is really not more. What your focus needs to be on now is more formal. It's just the real focus is seeing the forms in the instances, right? Just see and following the rules, right? So seeing that this, right? You need to be clear. You need to be able to see that this would-be application of simplification is not a legal application of the rule of simplification. Why not? The premise is not a conditional. Okay. Conjunction is also a pretty simple rule. Don't confuse it with addition, which I'll talk about in a minute. But the rule is, okay, two premises and a conclusion. If you're given, here's a statement of the rule, you're entitled to infer a conjunction if you are given both conjuncts separately. Right? Given P and Q, given P somewhere and Q somewhere, you're entitled to conjoin them, right, by the rule of CONJ, conjunction. Okay? You're entitled to do that. Right? The paradigmatic application of this, right, how you have to be thinking this rule in terms of its application is when you say C, and I'll be saying this again when we talk about working backwards, but when you're given as a conclusion, say, if you're given a conclusion which has the form of a conjunction, right? If your conclusion is a conjunction, if the formula you're asked to derive, the conclusion, has as its major operator a conjunction, is a conjunction, your thought should be, the last step in my proof is probably going to be conj. Right? It's probably going to be, I'm probably going to get this by deriving each of the conjuncts separately, if they're not already in the premises, and then conjoining them. Right? It's probably going to be the case that the last step in my proof is conjunction. You have to be thinking, okay, what is the form of my conclusion when you look at it? It is a conjunction. What rules have conjunctions as conclusions? Right? You'll hear me say this 50 times. What rules have conjunctions as conclusions? It is the rule of conj has that. I'll probably get it by conjunction. Okay, that's a first taste of what working backwards is going to look like. Okay, so when is it going to, you're going to need it when it's useful. So when's that going to be? Okay, look at a situation like this now, right? You've got the conclusion is G, that's what I'm aiming for, right? And these are my premises, 1, 2, 3, 4. So I want to get G. Let me do some working backwards. I'll ask, where does G occur? Plus or minus a negation amongst the premises. Say that 100 times. Here's G. That's what I need to derive. Right? This is the last step of my proof. G's here. Okay. It occurs as the consequent of a conditional. Okay. So when you're working backwards, 2 questions to ask. What rule am I going to use to get this? And what formula do I need to apply the rule? Okay, the rule I'm going to use to get this is modus ponens, because this is the consequent of conditional. And modus ponens allows me to infer, as my conclusion, the consequent of conditional. And what do I need to get it? What formula do I need to apply that rule? I need the antecedent of the conditional. I need A and B. Oh, I can get that by conj. And ignore, E is no use here, but I can go 5 A dot B. Now it's, see this now? It's by conj 1 and 4. Right, conj 1, 4. Right, 1, 4. Those are the 2 steps which are the premises of the rule. 1 and 4. So you see how this third part of the proof, you need the statement of the rule, its abbreviation, conj. Sorry, you need the formula, 1, the 2, part 2, the statement of the rule, and 3, the steps, which are the steps which are the premises. In this case, it's 1 and 4. And then 6, I'm done, right? 5, 2 and 5 modus ponens. M, P, 2, 5. Right, there you go, there's a proof. But see how I used conj when I saw that I could put these together to get the antecedent of that conditional.